Hello and welcome to Digitech. Today we're going to be continuing with our Cipher project. So you can see me just opening up GitHub Desktop, having a look, make sure it's the right repository, Cipher, and opening it up in Visual Studio Code. So in the last couple of videos we created an encryption and a decryption, and we changed it so that it had a shift as well. And I'm just going to collapse those functions and we can have a look at the HTML. So at the moment it's just got an input and a couple of buttons. And if you want to have a look at the details of those, the videos and projects are available. Now today we want to do an analysis function, because in the last one we added that shift value so that people couldn't just translate it directly from the character codes into text. They couldn't just look up the exact character code. We shifted them so that it's a different number, and you had to shift that number back before you translated it. Now we're going to cover the situation in which we don't know what the shift value is, and you've got to kind of figure it out. So we're going to add an analysis function where we can have a look at the frequency of things that are popping up. So by far the most common values in English are E and A and I and O. And those letters that we can, if we can see a character code that's popping up frequently in our analysis, we can make a guess. Maybe that one's E, or maybe it's I or O, or maybe even space if we're looking at like a longer string that's probably going to have separated words. And if we shift the values so that the most common letters line up with E and A and I and stuff, then we have a better chance at sort of decrypting that sentence. So here we're just setting up the buttons and doing a bit of console log to make sure the button click is working. Now we can start setting up our variables. Now the analysis function is going to do sort of two separate things. The first thing it's going to do is to sort of translate our ciphertext into separate character codes. And then it's going to look through all the character codes and count up how many times each one appears. So we're going to store all of the character codes in this codes array, and then we're going to have a look through that and sort of count up how many times each one appears so that we can start looking at the letter frequency. The first thing that we need to do is obviously do a bit of decryption. Now we're not actually going to decrypt from the character codes, so we don't need the from character code part, and we don't know what the shift is, so we're going to leave that out as well. But what we do want is to store each character code in our codes array. So this is just our adding to array line. So the codes is going to expand what codes already is and add char code onto the end of it. So that way codes is going to slowly build up, and if we're using a word like test or something like that, then it's going to add up like 116 and whatever E is, I can't remember. So this is currently a string separated by pipes, and if we hit analyze, we can see that it's now an array, and each item in the array is separated by a comma, and each item is its own character code. So that was kind of just a test output for the first part of our analysis, and the first part is obviously to get that array and get all the character codes. Now what we need to do is to analyze that array and see how many times each character code appears. So I'm going to start off with if codes.length. So basically if they haven't typed in anything into their input, then the codes.length will be 0, and you don't really want to output anything. So I don't really want to have to do all the work if there's nothing to do the work on. But if there is something in the array, then we need to sort the array, and we're going to start at the beginning. So we're going to let our current code equal the first code, and we're going to start our count at 0, and we're going to be counting every time that code appears in the array. And because it's sorted, we know as soon as it's not that code, we've counted all of them. So I'm going to use a for loop to go over the array. That's every time you're using an array, you're probably going to end up using a for loop in some cases, I guess, because it's just so useful to have that I value where we can get each individual thing out of the array. You could use an each loop or something like that, but I find the for loop is a useful thing to know how to use. So for every code in the codes array, if the code at this current position is the current code, we add 1 to the counter. So let's say you're looking for 116. If the next one is 116, you add 1. One after that is 116, you add another 1. If the next one's not 116, then you add whatever count you got up to. So let's say 116 was counted 3 times. So you're going to say 116 appears 3 times. And then you're going to reset your count to 1 because you're currently looking at a new code. So you need to count that one as well. So our current code gets updated to the one we're looking at. And because we're looking at it, obviously we count it. So it starts at 1. So that's our analysis. We're going to, if the codes exist, sort it and start looking through it and counting up all of the duplicates. And at the bottom, we're going to output the analysis, which should be like a bunch of lines that say this appeared this many times, that appeared this many times, etc. So now that we've got our code, we can see 104 appears 1 times, 118 appears 1 times, but 119 is not showing up there. It should say 119 appears 2 times. But I think the problem is that it doesn't do it for the very last one at the end of the array. So just after that for loop is run, we need to output 1 more time because we are just looking at the last item in that array. That's just a little quirk of the way that we've done it. So now when we analyze it, we can see there's 3 different things out of our 4 characters, but one of them appears twice. I'm going to add breaks at the end of this just to make it a bit more readable. And for that output, I'll put @HTML inside the brackets, which just tells Svelte that the output there, that text, has a little bit of HTML in it, and we do actually want to, show the text using the HTML. So you can do a little bit of kind of styling. And the BR just puts everything on a new line to make it a bit easier to read. So here in our analysis, we can see that 119 appears twice. And if you really wanted to start code cracking, you could start trying to kind of align that with the letter frequency. So if you just Google letter frequency in English, you can see the things that are the most common. Going to be E, A, I, and O. And on a short word like test, it's going to be really, really difficult to do letter frequency decrypting. But if you had like a big chunk of text, then the frequency of letters in that text is going to start to be the same as frequency in English in general. And you can start to make more educated guess about what the shift is actually going to be. So here we're just adding in a couple of comments because the code's starting to get a little bit more complicated. You can't just glance at it and see what's happening. So it helps to write some comments to describe what's going on. Who knows when we're next going to have a look at this, and it'd be nice to be able to catch up quickly. So we've got that version in there. We'll add in a little comment for our GitHub commit, making a nice descriptive note so that if anyone else wants to look at this, they can kind of see each of the different versions. So we'll commit that, push it up and save it on GitHub. And it's just uploading now. There's a few changes there, obviously. And under the repository menu, you could just click on View in GitHub to go straight there. We'll have a look at our source folder and our index file, and we should be able to see our changes on there. And there's our analyze function with all the stuff that we've just written. that'll do it for this part of the Cipher project. We've got encryption, which includes shifting. We've got decryption, which includes that shifting back. And we've got an analysis function in case we don't know what that shift actually is.